Here's our warm-up for today. There aren't any directions, so I'll just tell you out loud. The directions are to multiply. How would I multiply the first one? Yeah, this is just to distribute. So you get 2x squared plus 8x. And that's all you can do on that one. How about the next one, though? It's a little trickier. Instead of single distribute, we double distribute. Good. So we get x squared minus 6x plus 9x minus 54. Am I done? No, you have some like terms in the middle. So this is your final answer. What are your questions on this? So as you're copying this down, I'll just explain what we're going to do today. Today we're going to start factoring. Factoring is basically the exact opposite of what we just did. I will give you something like this. You will pull out a common factor to the front. Or I will give you a trinomial like this, and you will break it up into two binomials like this. After we learn to factor, we're actually going to solve equations using this. And when you solve equations using factoring, it tells you where it hits the x-axis. So it's another way to find the x-intercepts of our graphs. So kind of handy stuff. Any questions on the warm-up? No. Or the basic concept of what we're doing today?
Yeah, are we gonna
5.2 today. Like I said, we're going to do this over 2 days. So technically this is 5.2 day 1. Eventually we're going to solve quadratic equations. We're going to start, though, just factoring and then add solving at the end of today and then really look at it a little more in depth tomorrow. I would definitely write this down. So these are the methods of factoring. A lot of students, the hardest part about factoring is just knowing what to do. So if you have two terms, the first thing you want to look at is pulling out a greatest common factor. The next thing you want to look at is the difference of two squares. Now, these probably sound like familiar terms to you, but you're not really quite sure what they mean yet. We're going to review all these methods over the next 2 days. But right now, I just want you to kind of see when you would use each method so you could think of that as we're learning them. All right, if it's a trinomial, 3 terms, again, you want to start looking at greatest common factor, and then we're going to use the bottoms-up method. I'm pretty sure that's what you guys are familiar with. If not, we can look at other methods as well. But that's how most teachers here teach it. And then if it has 4 or more terms, again, look for greatest common factor, and then we will factor by grouping. If you're curious how we're going to break these up, difference of two squares and factor by grouping we're going to look at tomorrow. We're going to start today with GCF, and then we're going to finish today with bottoms up. The first method is greatest common factor. Now, you could write this down, or you can choose not to write this down. Greatest common factor is the easiest way to factor. Most students get this one pretty quickly. If you are someone who refers back to your notes a lot, I would get this in your notes. If you're more just watch examples and remember how to do it, I probably wouldn't write this down. It's really up to you. But whenever we're factoring uses greatest common factor, the first thing you want to do is find the greatest common factor. So we'll have a list of terms. Find out what they all have in common. We're going to write that out front. And then in parentheses, you write what you would have left over if you went through and divided each term by the greatest common factor. So essentially this process is the opposite of distributing. You figure out what they all have in common, you write it out front, and then you divide each term by that term out front. Remember, when we distribute, we multiply through by that term. So, like I said, pretty much the exact opposite of distributing. Here's our first example today. The directions say factor using GCF, so the greatest common factor. Looking at those terms, there are 3 terms, and the greatest common factor is 3. Good. So I will write a 3 out front, and then you're basically going through and dividing them all by 3. So what would you have left over in the first term? X squared. What would you have left over in the second term?
minus 2y?
Yep, minus 2y. What about the last term? Plus 4. Good. That's it. Now, eventually we'll get to ones where you can factor what's left over as well. So you might have to factor in 2 different steps. But the first couple of examples we're going to look at until we review the other methods, you're just pulling in GCF out. What questions do you have? All right, here's the second one. Again, we're just finding the greatest common factor. What is the greatest common factor here?
5x squared.
Good. 5x squared. What would you have left in the first term?
X squared.
X squared. Good. The middle term?
-2x.
Good. The last term? Plus 6. Wonderful. Not too challenging. Any questions? All right, so now we have 4 terms. But again, no matter how many terms you have, always try to do GCF first. Do we have a GCF? 4, good. So if you take a 4 out, what do you have left in the first term? Cubed, right? We didn't take any a's away. What about the second term? Good. Plus? 6w minus 3. Great. That is one way to do it. Did anyone want to do it a different way? Yeah?
Put the a cubed in front of the parentheses.
Well, they would have to all have an a cubed. Only the first 2 do. So we don't want to do that. What you could do, and what a lot of students will do on this one, is factor out a -4, since there's a lot of negative terms. If you factored out a -4, you would have a to the third plus 4a squared w minus 6w plus 3. You can see, though, if you distribute, you end up with exactly the same thing, so it doesn't really matter on this one which way you go. If this was my paper, I'd actually do it this way. It's just kind of what I'm used to. Usually if the first term is negative, you factor out the negative, but really either of these is completely fine. What are your questions here? All right, next one, bottoms up method. Again, really your choice if you want to write all this down. I will give you time to write it down if you'd like. The bottoms up method sounds kind of confusing, but once you get the hang of it, it's not too bad. The first thing you want to do is find your multiply number. You get your multiply number by multiplying the first and the last coefficient. Then you want to find your add number. Your add number is your middle coefficient. Then you find the combination that would multiply to your multiply number and add to your add number. Write these numbers in binomials. Then divide by the lead coefficient. Simplify if you can. If you can't, you move the bottom up. And then here is the most important step of all. Check your work. It is very common to make mistakes here. However, it is super easy to catch your own mistakes if you check your work. So, tons of steps. Last step, always check your work. Any questions as you're writing this down? All right, so in the bottoms up method, the first thing you want to do is find your multiply number. I'm just going to say m equals. And you multiply the first coefficient and the last coefficient. What is 2 times 6? 12. Good. Now, I should mention the 6 isn't actually a coefficient. It's a constant. But you see what I mean? First number and the last number multiply together. That's your m. And then your middle coefficient is your a. So a in this case is 13. So you start with multiply number, add number, and now we have to come up with a combination that multiplies to give you 12 and adds to give you 13. Yes?
12 times 1.
12 and 1. Great. Now, we write binomials using those two numbers. So x plus 12, x plus 1. I'm going to pause here for everyone to catch up, because here's where it gets pretty interesting. We go back and divide those two numbers by our lead coefficient, which is 2. Then we simplify. What is 12 divided by 2?
6.
6. Can you simplify?
1/2.
1/2. No, it just stays 1/2. Now, the reason we call it bottoms up method is after you simplify, if you have a fraction, you move the bottom up. So my final answer is x plus 6, 2x plus 1. That's bottoms up. Any questions on bottoms up method? Now, I told you the most important step is to check your work. If I do x times 2x, I get 2x squared plus 1x plus 12x plus 6. Is that going to give me the trinomial that I started with? Yes, it will. In the middle, you get 13. The first term is 2x squared. The last term is 6. So I am good. Even if you just check your work in your head, check your work. Now, when your lead coefficient is a 1, these go super quick. What's my multiply number on number 5? What's my add number? Negative 5.
Negative 6, positive 1.
Yeah, negative 6 and positive 1, right? Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Now I can write my binomials. All right, after we write our binomials, our next step is to divide by the lead coefficient. What's the lead coefficient here? 1. Does dividing by 1 change negative 6? Does it change positive 1? Do we need to move any of our bottoms up? No, so we're actually done here. Number 6, what's my multiply number? Add number? Yeah, negative 6 and negative 3. Negative 6 times negative 3 is positive 18. Negative 6 plus negative 3, negative 9. Oh, there's a typo here. Anyone see it? Yeah, this should be a y. My bad. Or they could both be x's. If they were not the same, like if this was on your homework and they weren't the same, I would just say you couldn't factor it. You can only factor it if these are the same. One's squared and one's to the first. But I know for a fact this is just a typo, so I apologize. All right, now we go back and divide by our lead coefficient of 1. Does that change negative 6? Does it change negative 3? Do I have to move any bottoms up? No, so I'm done on this one. What are your questions on 5 and 6? Like I said, it's a lot easier when you don't have to go back and divide, since your leader is a 1. All right, here's 7 and 8. What's my multiply number on 7? What's my add number? Anybody know the combination? 14 and 1. Good. So R plus 14. R plus 1. Do I need to do anything else?
Nope.
Nope. I would go back and divide by a 1, which is not going to change anything, so I'm done here. I haven't been checking my work, but really we could. This is R squared plus 1R plus 14R, which will give us the 15R plus 14, so I'm good. All right, number 8, my multiply number. My add number. 4. Anyone know the combination? 6 and negative 2? Good. So Q plus 6. Q minus 2. Do I need to do anything else? Nope. I would divide by a 1, which isn't going to change anything. So I'm good. I am going to just kind of think about checking it. This would be Q squared minus 2Q plus 6Q. That's going to give us 4Q minus 12. So I'm good. Any questions? What's the multiply number?
24. Negative.
Negative 24. What's the add number?
2.
2. Good.
Negative 6, positive 4. Or positive 4, negative 6.
Negative 4, positive 6.
Yeah, you had your signs backward. It's negative 4, negative 6. A good hint on that, if you're not sure which way the sign should go, remember, to add to a positive number, the bigger number needs to be positive. All right, if this would have been a negative 2, then the 6 would need to be the one that's negative. All right, so negative 4 and positive 6. So x minus 4, x plus 6. Then what? Yeah, divide them both by 3. Does the first one divide by 3? No, so what can I do? Yeah, move the bottom up. I'm just going to write it as 3x minus 4. What about the back one? Yeah, just make it a 2. And I'm done. Very important to check on this one. So this would give us 3x squared. That's good. It will give us plus 6x minus 4x. That'll give us positive 2x. And then a minus 8 in the back. So, like I said, you can just check in your head. It doesn't take, what, 10 seconds. So, any questions? All right, multiply number. Add number. 3. Good. So multiply to 4, add to 3. Someone said 3 and 1. Well, 3 times 1 is 4. 4.
Negative
4 times 1 is 4, but 4 plus 1 is 5. If you made them both negative, negative 4 plus negative 1 is negative 5. The only other way to get 4 would be 2 and 2, but that would add to 4.
Can I do it?
What do you guys think? So yeah, not all trinomials can be factored, so just make a note. Can't be factored. Good, any questions? Great, yeah, if you can't factor it, just write can't be factored. Not all of these are possible. But I will tell you what, a lot of people would just say 4 and 1 on this one. Make sure you're actually thinking about these. Don't just go with the obvious answer. Double check to make sure it works. Any questions? All right, last little topic today is called the zero product property. I'm sure you've seen this before. We actually used this already in this chapter when we were graphing using the intercepts method. Remember, I said that solutions for these are just x-intercepts. So what this property says is if a and b are real numbers or expressions, and you have a times b equal to 0, then either a equals 0 or b equals 0.
Do we use this for the polynomials?
Mm-hmm. Yeah, when you're solving equations with polynomials, that's when you would use this. So if there's no equal sign, you just factor. If there is an equal sign and it equals 0 and it says solve, that's when you use this property. So we'll look at some examples after this. But like I said, we already used this when we were finding x-intercepts yesterday in intercepts method, so it's not completely new, but now we're just formalizing it. So here's 2 examples when we would use this property. So the first thing you want to do is make sure they're already equal to 0. So I said these are the same thing as the x-intercepts. Remember, when you're finding the x-intercept, you make y 0. So yesterday when we looked at these, this said y, but we turned the y into 0 because we were finding the intercepts. So that's how this relates to what we did yesterday. But when it's equal to 0, the first thing you want to do is factor it. You want to break it up into factors. So how do I factor 11? Well, it's a trinomial, so we should try the multiply add. Good. Multiply to 2, add to 3. Anyone know what the combination is? 2 and 1. So I have x plus 2, x plus 1 equals 0. Go back and divide by the lead coefficient. The lead coefficient here is 1, so I'm actually good right where I am. Now, the zero product rule says that for this times this to be 0, either the first one equals 0 or the second one equals 0. Do you know what the solutions are? We just solve for x. We get -2, and we get -1. Great, and you can double check these by plugging -2 into our original equation. You will get 0. Plug -1 into the original equation. You will also get 0. Great. How do I start number 12? Same way. Multiply to -2, add to -1. Anyone know the combination? Yep, -2, +1. So z minus 2, z plus 1 equals 0. Then what? Yeah, set them equal to 0. We don't have to worry about the division step because our lead coefficient was 1. Alright, on this one I would add 2. So 2 is a solution. Here I would subtract 1, so -1 is also a solution. Again, sorry, it's behind that little emblem. Z is 2 and -1. Questions on these? Alright, I said this only works if it's set equal to 0. These are not set equal to 0, so what do you think I need to do? Make them equal to 0. How would you make the first one equal to 0? Yeah, you'd subtract 8x and you'd add 1. So this would be 16x squared minus 8x plus 1 equals 0.
Could we just subtract 16x squared?
That's a really good question. Can you subtract 16x squared? These get a lot more difficult when your lead coefficient is a negative. So when possible, I would keep the lead coefficient positive.
Okay.
It's a very good question. All right, now we can do the MA method. So multiplies to what? 16 adds to -8. -4 and -4. So x minus 4. X minus 4. What do I divide those each by? 16. Good. Those will both reduce to 1/4 and 1/4. I should have given us a whole slide for this one. So when I move the bottoms up, what would I get? Yeah, and I'd have that same thing twice, right? So I could just write squared equals 0. So either 4x minus 1 equals 0 or 4x minus 1 equals 0. Do you think you actually need to solve it twice? No, you're going to get the same thing. So just do 4x minus 1 equals 0. We're going to add 1 to both sides. Then divide by 4. So what's my solution here? 1/4. Good. Sorry about cramming all that in. Let me know if you'd like me to expand it a little bit. I can clear this page and do it again if we need to see it. All right, what about this last one? This is our last example for the day. How would we start it? It's called the zero product rule. So what do I need? I need it to be equal to 0. Good. So I'm going to do that by getting that z over with the z squared. So I have z squared minus z equals 0. How do I factor something like this? Do what? Yeah, divide by 1z or take out a z. So that would leave me z minus 1. So how would I solve this? Yeah, these are still just two factors. So z equals 0, that one's already solved. Or z minus 1 equals 0, in which case we just add 1 to both sides. Yep, so our solutions are 0 and 1. What are your questions? All right, here's your homework. It's also listed on your green sheet. Just like the homework from Monday and Tuesday, you have 2 nights to do this. So this is Wednesday and Thursday's homework assignment. I think you will be able to do the first 2, maybe 3 sections. It is a pretty lengthy homework assignment. You can see it goes from 23 to 79. Only the odds, but it will take you a little time, so I would not wait to do this all in one night. I would do at least the ones you can tonight, and then we'll learn the other ways to factor tomorrow. Any questions?